Hey, Honors Algebra 2 and Algebra 2 students. What we're going to be doing today is doing the last video in this unit. And so we're actually going to cover two sections. So you can kind of do this, hopefully it's not super long of a video, but there's kind of a lot of information. But I wanted to kind of make sure that we cover all of our bases. All right, so first and foremost, we're going to talk something about frequency. And so frequency is kind of like the period of your function, right? How quickly or how often something repeats. But use frequency with stuff like wave sounds, or anything that has like a motion of a pendulum, or anything that's like cyclical, like seasons of a year. So what I need you to know is that frequency has kind of its own little formula. So frequency equals 1 over period, which basically just means we already know the formula for the period, right? So frequency equals, if this is 2 pi over b, 1 over 2 pi over b is b over 2 pi. So when we talk about frequency, we're kind of taking the reciprocal of that period, and then that's how we calculate the frequency of that particular thing, whatever it is that we're talking about. The other thing I want to talk about is something called a sinusoid. And so what this means is a sine graph or a sine function or a cosine function. So if you haven't already caught on to the fact that we can write every function, every sine cosine function can be written as the opposite. In other words, every graph that's either a sine or cosine function can be written as a sine graph or a cosine graph. So we can make those equations kind of match, and I'll show you how to do that here in a bit. By the way, I'm on page 269 if you hadn't already noticed. All right, we're actually going to turn to page 270. We're just going to go through a bunch of examples. So this first one, talking about kind of a story problem. It's talking about the alternating current generator, or an AC generator, converts motion to electricity by generating sinusoidal voltage, assuming that there's no vertical offset, in other words, and no phase shift. In other words, that it's not shifted left to right or up and down. The voltage oscillates between negative 170 and positive 170 volts with a frequency of 60 hertz. Write and graph a sine model that gives the voltage V as a function of time. So when they say voltage V as a function of time, they mean V of t. And so when I was looking at this, the first thing I noticed was the fact that, number one, there was no phase shift, no H and no K. But it did tell us that it oscillates between 170 and 70. So what they're giving us here is our amplitude. So it's oscillating between 170 and 70. We know that the midline has to be right here at y equals 0 because it doesn't have any shifts involved. So we know our A value in this graph is going to be 170, a unit of 170. What we want to figure out now is the B value. So if we're writing an equation, generally when we write an equation, we want A, if we're going to do a sine function or cosine, B, and then x minus h plus k. Well, we don't have an h and k for this one. We know the A value is 170, and we just have to now figure out the B value to write our equation. So we're going to use that information about frequency to be able to figure out our B value. So the frequency is going to equal B over 2 pi. So in this particular example, we know that the frequency is 60. So 60, I'm going to put it over 1, equals B over 2 pi. So let's solve for B. So I'm going to cross multiply, and I get 120 pi. So when I write my equation, I can now substitute in A and B into my equation. So I know that this is going to be 170. We said it was going to be a sine graph because it asked us for a sine model. And then our B value is 120 pi and x. So don't forget your x, because obviously that's what you're taking the sine of. And there is no h and k. So what this would look like is a graph that's going to kind of do this, right? Start at a midline because it's a sine function, go up to a max, midline, midline. And the frequency, since the period or the B value is 120 over pi, that means the period of the function is 2 pi over 120 pi, which gives me 1 over 60. So this is actually 1 over 60, that distance here. And so that's all I really need you to be able to do. It said to just kind of sketch a graph, and we weren't like getting really specific, but that's the equation. So what we're going to kind of focus on in this section in 9.6 is really kind of writing the equations of all functions given a graph. All right, so let's practice a few more. So in number 2, it says write a function for the sinusoid. So again, this means you can write a cosine function or a sine function. And there's going to be times in which one is better than the other. All right, so here's kind of my steps. I like to kind of write down kind of a game plan. So step 1, if you're writing the equation given a graph, is to find the b value. So you want to use the formula 2 pi over b. So in other words, we're finding the b value using 2 pi over b equals our period. So when you look at a graph, what we're looking for is what is the period of this graph. So it's helpful to notice, you can measure this kind of looking at one complete revolution, but notice what they provided for us on this graph. They gave us a max and a min. And so I know that from one max to one min is half of a period. Okay, because it goes from midline max, midline min, midline. So this one distance here is half of a period. So what I'm going to do is I'm going to figure out the distance. So what is the distance on my x-axis? Remember, we're talking about the period, which is your x-axis. So I'm going to take my x values and I'm going to subtract them. So I'm figuring out the distance on my x-axis from this max to this min. So I'm going to take pi over 2 and I'm going to subtract pi over 6. And so all I'm doing here is just finding a common denominator. So I have 2 pi over 6, which actually equals pi over 3 if I reduce it. So remember, this is this distance on your x-axis from one max to one min. But we're going to multiply this by 2 to figure out the whole period. So 2 pi over 3 is the period of this function. So why that's important is now that we know the period, we can go ahead and find the b value. So remember, the period formula is 2 pi over b, so that equals the period. So I'm going to set it equal to 2 pi over 3 because that's the period of this function. So I took the formula for period and I set it equal to the period that I just figured out. So now all we're going to do is we're going to cross multiply and I'm going to solve for b. And I get b to equal 3. So again, why that's important is because we need to figure out an a, a b, an h, and a k in my equation. So I need to figure out all of those letters. All right, step number 2. Find the midline of your graph. Why we do that is because your midline is your k value. Remember, we need to find all of our values. So we have b already, but we need to find the rest. So if you look at your graph, your midline is going to cut your graph in half. So halfway, or it's halfway between your max and your min. So if halfway between 0 and -2 is 0. So my k value is 0. So I'm just going to write that kind of on the side here, that my k value is 0. Once I know that, I can find the amplitude. The amplitude, remember, is just the distance from the midline to the max. So from my midline to my max, or midline to your min, is a distance of 2. Remember, your amplitude is always positive because it's your a value. It's a distance. So we have an a value, a k value, a b value. So think back to our generic equation. We have a, b, h, and k. So all I really need now is my shift. So step number 4, before we figure out any kind of shifts, is we want to choose whether or not we want to write a sine or a cosine function. Here's how I make that choice. Now again, you can do either. Sometimes there's going to be an easier option, but you can do either of these graphs. So I always look at my function. If this starts at a midline, like at the origin, it starts at a midline, I'm going to use sine. If it starts at a max, I would use cosine. And so again, I can show you how to write both. Let's do a sine function first. So we're going to choose sine. So here's my generic equation. I'm going to plug in everything I know. So I'm going to plug in 2 for A. I'm going to plug in 3 for B. Since it starts right here at the origin, I did not shift it left or right, which means there is no H value and there is no k value. So this would be my equation to represent that graph. All right, well, let's do another one, but this time I'm going to do a cosine function. So let's say I wanted to do a cosine function. Same deal. So we choose a sine or cosine, and I should put the last step in here, which is find your h value and write your equation. So what I mean by that is if there's a shift, right? So, okay, let's go back to our graph. Let's say I wanted, okay, I still have my a value. Let's say I wanted a cosine. Still have my b value, which is 3. None of that changes. The only thing that's going to change here is my shifting. So rather than, we know a cosine function starts at a max. So find your first max. So my max up here, right there, that is a shift of right pi over 6. So that's what you need to include in here, is a shift of right pi over 6. And then your k value is still 0. The only difference between these two functions when I write one as a sine or a cosine is the fact that we shift it either left or right. And so either one of these would be correct, and there's actually, you could do a different multiple of either one of these. So there's a lot of correct answers for this. But what I'm trying to get at is you can write every function as a sine and a cosine. Let's do another one. Let's do this next one, number 3. So again, let's start with our beginning value. Let's find our b value. So let's figure out the period. So you could do this by, I look at, this was my minimum, this was my maximum. So it gave me from 0 to 1 is my on the x-axis from 0 to 1. So that's a distance, obviously, of 1. And if I double it, I get 2. So that means the period of my graph is a distance of 2. So that should match, right? So if I start here at 0, I go 1 complete revolution, I end at 2. So again, remember when you're finding your b value, it's always your distance on your x-axis. All right, so let's use that b value, or use that period to figure out my b value. So you take the period formula, set it equal to the period that we just found, so in this case is 2, cross multiply, and solve for b. So I get b to equal pi. So again, this is one piece of my puzzle, right? I need a, b, h, and k. Next step says find the midline. So it looks like my midline's right here in the middle. So I have a k value. That's 0 again. My a value is your distance from the midline to the max or midline to the min, which looks like it's a half. And the only thing I need to do now is figure out my h value. So at this point, we need to choose whether or not we're doing a sine or a cosine. So again, I look at the origin. I'm starting at a minimum. I'm going to write a reflected cosine function. So the reason I'm doing this is because I'm starting at a min. If I was starting at a midline, I would use a sine function. But because I'm starting at a minimum, it's a cosine function. So min or max, I would start at a cosine. And since it's at a min, we know it has to be reflected. So now I'm just going to kind of plug in all of my values. I know this is a half. I know my b value is pi. Since this is right here on the y-axis, I did not shift my function. So the h value is 0 and my k value is 0. So here is a cosine graph that or cosine equation that represents that function. All right, there's 2 more on the next page. I want to encourage you to try these 2. Okay, so try these 2, see if you can do them yourself. I'm going to give you the answers right now. And that way you can kind of check your answers at the end. So if you don't want to see the answers, just pause the video, try these 2 on your own, and then come back and check the answers. All right, so the answers are, one possible answer, I should say, is over here. Just kind of write it on the side, and then I got 3 cosine of x for number 5. All right, let's do a story problem together. So let's do number 6. So it says the pedal of a bicycle wheel is 7 inches long. The lowest point of the pedal is 4 inches above the ground. A cyclist pedals 3 revolutions per second. Write a model for the height of in inches of a pedal as a function of time in seconds, given that the pedal is at its lowest point when t equals 0. All right, I'm going to go ahead and draw a circle. The first thing I know is that if you're talking about a wheel of a wheel of a bike, right? So the pedal's in the middle. So it says the pedal is 7 inches long. So the pedal's going to go around the circumference of this circle. So what I know is that radius, by telling me that the bicycle wheel is 7 inches long, the pedal of the bicycle wheel is 7 inches long, what it's telling me is that this distance here, because remember the pedal goes all the way around and all the way around and all the way around. That's how the bike moves. So that pedal is 7 inches long, which implies then that all of the radii, so this is 7, this is 7, right? If it's a radius of a circle, they're all 7. The other thing here is that it is starting at 4 inches above the ground. So remember, the wheel isn't obviously sitting on the ground. You wouldn't be able to do much, right? It has to be kind of hovering above. So a couple things that I did. Is I figured out, the first thing I figured out was if I'm going to write an equation to represent this relationship, okay? So imagine that you have a graph. So I'm going to go ahead and kind of draw like a coordinate grid. So at t equals 0, it says it's at its lowest point. So the lowest point would be down here, right? Because that's the bottom of the wheel. It's still 4 inches above where the ground. So my lowest point is at 4 inches. Then it goes around the circle. Its highest point then would be plus 7 plus 7. So 4 inches plus 7 is 18 inches. So what I'm giving you is it's starting at 4 inches. The pedal is 4 inches off the ground. Now it's 11 inches off the ground right here, and now it's 18 inches off the ground. So what I'm giving you now is your max and your min. Okay, so I'm telling you that it starts at 4 and goes up to 8. So if I figured out halfway between 4 and 18, because that's my distances, this is going to be my midline of my graph. So by doing that, what I figured out is that my k value is 11. So my minimum is 4, my max is 18. In between would be my k value, which is 11. My a value, which would be my amplitude, would be your distance from the midline to the max. So think of it on the circle would just be from here to the top, right, which is 7. Or from 11 to 18 is 7. All right, so we need to figure out the b value and then if there's any h value involved here. All right, so the cycle pedals 3 revolutions per second. That's kind of the key point here, 3 revolutions per second. So 1 revolution then, if I'm going 3 revolutions per second, 1 revolution would then have to be 1/3 of a second. Let me say that again. If it's 3 revolutions equals 1 second, then 1 revolution has to equal 1/3 of a second. Okay, so that means this pedal goes all the way around your bicycle wheel in 1/3 of a second. So that's that period, right? 1 revolution of your graph. So take the formula for period, set it equal to your 1 revolution, which in this case is 1/3. Cross multiply, and you get a b value of 6 pi. All right, so now let's graph our function. All right, it said we start at the lowest value. So we know our b value is 6 pi. So we can actually graph this if we wanted to and put in, some values here. Our next point would have to be at the midline. So if we're starting down here at a min, then my next point would have to be at a midline. My next point would have to be at a max, a midline, and a min. So that's my graph of my function. So now if I write my equation, I would probably choose a cosine function. I would actually choose a reflected cosine function. So I would do negative a, which a was 7, cosine of b, which is 6 pi. Since there was no shift away from the origin, and then I have a k value of 11. So that would be your equation. I want to encourage you to try number 7. Okay, I'm going to give you the answer here in a second. So try it, stop the video, try number 7, see if you can come up with the right answer. So I'm going to write the answer down now, so if you don't want to see it, stop the video. Let's see if you can get this correct. All right, check your answer against that, and then, of course, if you have any questions, obviously, we need to make sure we go over those in class. All right, we're going to now jump ahead to 9.7. So I need you to turn to page 274. All right, you're going to want to have this page handy. I'm not going to make you memorize any of these. You are actually going to do most of this stuff, and you're going to do a review of this stuff in pre-calc next year, honors pre-calc. So what we call these are trig identities, okay? And so these are just different rules that we've learned about trig. And so again, I'm not going to make you memorize these, and so you're going to want to keep this page handy. So what a trig identity is just a rule, okay? So for example, these are all our reciprocal identities. Cosecant of theta is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, okay? Makes sense. Remember, tangent is the distance of y over x, right? Opposite over adjacent, which was on our, kind of, we think back to that unit circle, was the distance y over x. Since sine is y and cosine is x, we could call tangent sine over cosine. Likewise, cotangent is the reciprocal of tangent, so we could just flip that, and then cotangent could be cosine over sine. Okay, these are called Pythagorean identities. So what this means is that we're talking about like a squared plus b squared equals c squared. So what we're getting at here is kind of using, there's a relationship that we know between our radius on a like if we talk about a value on our circle, right? This is our y value, this is our x value, and if it's a unit circle, then we know that's 1. So a squared, which is x squared, b squared, which is y squared, has to equal 1 squared. Okay, but remember, x we can substitute in cosine, and y we can substitute in sine. And so that's where that Pythagorean identity comes from. So for whatever reason they put sine first, but sine squared theta, cosine squared theta equals 1. Notice that the squared is on the sine and not on the angle. So just a little bit of technical difficulties here. All right, 1 plus tangent squared theta equals secant squared theta, again for the same reason. And then 1 plus cotangent squared theta equals cosecant squared theta. All right, the cofunction identities. What this means is, remember how we talked about in an acute angle? Okay, so let's say I have a triangle, right? And let's say this is a 30-degree angle, which means this has to be 60 degrees. Another way of writing that is calling that 90 minus theta, okay? So that's what they're getting at here, 90 minus theta, or pi over 2 minus theta. So what they're saying is the sine of 30 degrees. So if, let's say this is 1, this would be 2, this would be root 3. Okay, kind of our special right triangle. So the sine of 30 degrees is opposite over hypotenuse, or 1 over 2. Well, what they're saying here is the sine of 30 degrees is the same thing as saying cosine of, so sine of 30 degrees is the same thing as saying cosine of 90 minus 30. In other words, cosine of 60 degrees, which would be adjacent over hypotenuse. So the sine of one acute angle in a triangle is equal to the cosine of the other acute angle. And that's all they're getting at here. So the sine of one acute angle is equal to the cosine of the other one. And so they're kind of going both directions here. And then the tangent of one acute angle in the triangle is equal to the cotangent of the other acute angle. So it's just getting at the fact that those relationships are the same. Negative angle identities, the sine of a negative angle is equal to so because a negative angle here would be in the 4th quadrant, that means our distance of y would be negative. And the cosine of a negative angle, because cosine is positive in the 4th quadrant, so the cosine of a negative angle, this x distance is positive. So the cosine of a negative angle is going to equal a positive cosine. And the tangent of a negative angle is going to equal a negative tangent, and that's because your y value is negative. And remember, tangent is y over x. So negative divided by positive would result in a negative. All right, so I don't expect you to have these all memorized, okay? Let me first make sure you understand that. I do not expect you to have these all memorized. What we're going to do is we're going to use these to kind of help us do, I like this stuff. It's going to help us do some simplifying with some of these ratios. So have this sheet handy. What I would like you to do is to turn to page 275. We're going to work through a bunch of examples here, okay? So bear with me. So the first one says find the values of the other 5 trig functions. So I'm not going to do all of these because I don't really want to, but I'm just going to do number 1 and we'll kind of go from there. And if you need me to do others, we can do them in class. So first and foremost, it says sine of theta is 1/2, and then it gives you this range here. It says theta is between less than pi but greater than pi over 2. So let's think about that. Less than pi but greater than pi over 2. So less than pi would be here, greater than pi over 2. We are talking about the second quadrant. So what all this part right here is getting at is saying this is quadrant number 2. They're telling you what quadrant you want your answer in. All right, so what I would do here is I would draw my right triangle in this quadrant. Here's theta, right? That's your reference angle, that acute angle. If sine is 1/5, so remember, this doesn't have to be on the unit circle, which means that our radius doesn't have to be 1. I'm not telling you this is on the unit circle. So if sine is 1/5, that means the opposite and hypotenuse side is 1/5. You need to figure out the other 5 trig functions, which means you need to figure out this side. The easiest way to do that is to use Pythagorean Theorem. So 1 squared plus b squared equals 5 squared. Remember, you have to put the hypotenuse as your c. Okay, let's do some math here. I'm going to subtract. I get b to equal square root of 24. Since we're talking about a distance, we are going to, we're going to reduce this to 4 times 6, which is 2 root 6. So this distance here is 2 root 6. Because it's in quadrant 2, and that represents an x distance, it is going to be negative. So this is a negative 2 root 6. So I get what you're saying here. You're like, well, how can a distance be negative? Because we're referring to its position on a coordinate grid. So think of it as you're going backwards 2 root 6. All right, now that you have all those missing pieces, now you're just finding the other trig function. So you already did sine. So cosine would be adjacent over hypotenuse. So 2 root 6 over 5. Tangent would be opposite over adjacent, so 1 over negative 2 root 6. So you have to rationalize this. So we're going to multiply top and bottom by root 6. I'm just going to put the negative out in front. So I get root 6 over 2 times root 6 times root 6. Remember, root 6 times root 6 is just 6. So 2 times 6 is 12. I'm going to do, now I'm going to do cosecant, which is the reciprocal of sine. Remember, sine was the one they gave us, so the reciprocal of 1/5 is 5. I'm going to do secant, which is the reciprocal of cosine. So I get negative 5 over 2 root 6. I have to rationalize. I get negative 5 root 6 over 12, because 2 times 6 is 12. And then last but not least, I'm going to do cotangent, which is the reciprocal of 1 over negative 2 root 6, which is negative 2 root 6. So those would be your other 5 trig functions. I'm not going to do the other 3, but they're all very similar, okay? You might want to get another sheet of paper because it does take a little effort or a little room here, and they don't give us enough room on this paper. All right, so that one wasn't too hard. Now, those were kind of ones we've done before. Let's use our trig identities to help us simplify expressions. So what they're having you do here is they want you to simplify this. And a lot of times what that means is they want you to rewrite that in terms of either sine or cosine. So let's think about tangent. Remember how we can rewrite tangent. Tangent is written as sine over cosine. So I'm going to rewrite tangent as sine of theta over cosine of theta. I'm going to rewrite secant. Okay, so I'm going to rewrite secant. Remember, secant, if we want to write it in terms of sine or cosine, secant is 1 over cosine. So I'm just changing this into an equivalent form. So I took tangent of theta, rewrote it as sine over cosine, took secant as 1 over cosine. Let's do the math here. So this is negative sine of theta over cosine of theta. When you divide by a fraction, you multiply by the reciprocal, right? So you flip that. So what happens here is my cosines are going to cancel out, right? Because cosine divided by cosine would equal 1, and I'm left with negative sine of theta. That's what they mean by simplify the expression. So take this and simplify it down to negative sine. All right, let's do another one. Cosine of pi over 2 minus theta. Well, remember, that's this one. Cosine of pi over 2 minus theta is equal to sine. So I'm going to rewrite this as sine. And then 1 minus cosine. 1 minus cosine. So, I'm sorry, 1 minus cosine squared. If I changed this identity and just solved for sine squared, I would get 1 minus cosine squared equals sine squared. And that's what I'm going to use here. So 1 minus cosine squared, I'm going to substitute in sine squared. Okay, so what's sine times sine squared? It's kind of like asking you, what's x times x squared? It would be sine cubed. So this is just us using our trig identities to simplify expressions. That's all this is. All right, let's do some more. On this one, it says 2 secant squared theta minus 2 tangent squared theta. So what I'm going to do is I'm going to substitute secant squared theta. So remember, I look back here and I see, okay, secant squared, where's that one at, is equal to 1 plus tangent squared. I guess we use x instead of theta, which is fine. And then minus 2 times tangent squared theta. And I could substitute something in for tangent squared, but I'm going to go ahead and wait on that one. And then tangent of negative x. So tangent of negative x, that's those negative things. So tangent of negative x is equal to negative tangent of x. So I'm just going to substitute in here negative tangent of x. And then cosine of negative x. Cosine of negative x is equal to cosine of x. So I'm going to substitute that in. And then let's simplify. So I'm going to distribute this 2. So I get 2 plus 2 tangent squared x minus 2 tangent squared x over negative tangent x cosine x. All right, so you might notice here that this and this cancel, right? 2 tangent squared x minus 2 tangent squared x is going to cancel out. So I get 2 over negative tangent x cosine x. Okay. What I'm going to do next is I'm going to rewrite tangent. So I'm going to rewrite this as 2 over negative sine of x over cosine of x. And I'm going to rewrite, and then I have cosine of x. So all I really did here is just rewrite tangent as sine over cosine. Notice though that my cosines cancel out. So now I have 2 over negative sine of x. And then if you remember, we can kind of separate this. If you think about it, 1 over sine of x is cosecant of x. So think of it as 2 over, and you can move the negative up to the top, that doesn't really matter. 1 over sine of x, right? So this and this are equal, right? 2 over sine of x is equal to negative 2 times 1 over sine of x. And so then I can rewrite 1 over sine of x as cosecant of x. And that's how you would simplify it. All right, I would encourage you to try some of these. I would try number 8, and then I would try, let's see here, I will do number 9 together, and then I would have you guys try number 10. All right, let's do the number 9 together. So on this one, it asks you to verify the identity. And so what that means is you're going to simplify one side of your equation so it equals the other one. So I'm going to start with 1 minus cosine squared theta. And then I am going to start with this side. So I'm going to change 1 minus cosine squared theta. I'm going to change that into sine squared theta. And then I have secant squared theta minus sine squared theta. All right, so I'm going to get this side of my equation to equal this side. That's my goal. All right, so I need to get this all kind of in signs in order for this to be sine to the fourth. So I'm going to rewrite this. I'm going to rewrite secant as 1 over cosine squared. So again, secant, if you remember, is just 1 over cosine, so that's why I substituted that in. So then I'm going to do this division. Okay, so I have sine squared theta over 1 times cosine squared theta over 1 minus sine squared theta. So I just did this division here, so I changed it to multiplication. So what this gives me is sine squared theta cosine squared theta, those are being multiplied, minus sine squared theta. All right, so this is kind of where this trig stuff and this going back to quadratics, this is a binomial. Notice that they both have a sine squared in common. You can factor out a sine squared. So I factored out the sine squared out of here. Now, what is cosine squared minus 1? Well, we talked about that one. Cosine squared minus 1 gives me negative sine. So this one would give me negative sine squared. So then negative sine squared times sine squared would give me negative sine to the fourth. And that is where I kind of started with. Okay, I am going to do number 10, and then we're going to call this video the end. All right, so number 10, this is a little bit different one. So they're going to have you start with cosecant x plus cotangent of x. So what I'm going to do is I'm going to rewrite cosecant, because I need it in sine or cosine. I'm going to write it as 1 over sine. And I'm going to write cotangent as cosine over sine. So I'm going to rewrite it like that. So these are just fractions, right? So I'm going to combine, so they have a common denominator. So I can add them together, and I get that. So here's the issue, and I don't think you would know how to do this unless I showed you. So how am I going to get this, right? How am I going to get that reciprocal? So this is a tactic that we use. So sometimes if you're trying to get like the opposite, in other words, 1 minus cosine, it's on the top, this one's on the bottom. What you want to do is you want to multiply by whatever it is that you're trying to find. So in this case, I'm going to multiply by 1 minus cosine of x. The reason I can do this is because multiplying that equation or that fraction by 1 minus cosine of x over 1 minus cosine of x is just like the same thing as multiplying by 1. So I didn't change the value any. So I need you to distribute across the top. So anytime you have a binomial where one parenthesis is positive, one's negative, that's that difference of two squares. You get 1 squared minus, and then you get cosine squared x. On the bottom, I'm going to get sine of x times 1 minus cosine of x. Okay. 1 minus cosine of x is sine squared of x. All right, so notice that I have a sine squared x over sine of x. Because these are both factored out, I can reduce that. It's kind of like having an x squared over an x. So I can get rid of one of the signs on top. It cancels with one on the bottom. And that's how I end with that. Okay, so here's what I would have you guys do. I would have you try number 8 if you want, and I will tell you that the answer to number 8, so pause the video if you don't want to hear it, the answer to number 8 is actually -1. So see if you can get this to reduce to -1. That's kind of a challenge for you. I'm going to do another video on 9.8 just to kind of give you guys the last section of this, just so that video isn't super long. All right, if you have any questions, bring them to class. Bye for now.